I do have a lot of background in machine learning. It's what I went to graduate school for, artificial intelligence. I've spent most of my career as either an ML researcher or someone who's commercialized AI-enabled technologies. And one thing that I've learned in that time, one truism, is that really great data with off-the-shelf models always outperforms, we'll say, limited data with best-in-class models. And so a lot of our customers, I think there's always this natural bias to sort of chase what's getting all the attention. We need to invest in the latest and greatest models, and we need to hire the legion of PhDs in data science to make sure that we're engineering the very best architecture of neural network and we're using the latest generation of big model transformer or whatever. Those things do matter. But I will say at the periphery, if you don't have your data state correct, it just you don't even get the chance to sort of be accurate later on with the models.
Welcome to Software Snack Bites. I'm your host, Shomik Ghosh of Bold Start Ventures, and today we're excited to have Andrew Sellers on the pod. Andrew is head of technology strategy at Confluent and was previously the CTO of the U.S. Air Force Academy. And so in this episode, we're going to cover a little bit about technology in the government, but mostly around the role of data and streaming in kind of this modern AI world. So Andrew, thanks for joining.
Sure, it's my pleasure. Thank you so much for having me. I've been looking forward to this, so this is going to be great. Yeah.
I'm excited to dive in, but let's start off with, because I think the Air Force background is just kind of something really unique. We don't see it that often actually in the enterprise software world, and so just kind of start off with your background there. What does the CTO of the Air Force Academy do? Are you like choosing the entire tech stack the students are learning? Are you having to manage the security side thing? What do you actually do as the CTO of the Air Force Academy?
Yeah, it's a great question, and it's a position that it does a lot of what you described there. We set strategy in that office, and then you choose a lot of vendors to help align to that strategy. It's not like a lot of places I've been since. You have this big sort of in-house development team, and that was not a luxury we had there necessarily. And so a lot of sort of the actualization of the strategy is about picking the right vendors and the right partners to help you kind of realize your vision. And so, there is a operational Air Force that I had come from, where I did a lot of lead architecture work. And so I knew that stack inside and out about how we operationalized our enterprise services and how we did that securely, how we communicated across the globe within ourselves, within, we'll say other joint partners, within even, NATO allies in particular and others. And so there's a lot involved in that, as you can imagine, how one does identity and access management, how one does, security gateways, and how one, actually, provisions and delivers and, maintains services. And so the goal with U.S. Air Force Academy job then was to sort of make that as close to the U.S. Air Force as we could, while still fulfilling that mission of being an educational institution. And so this is probably a good time as any to kind of let out the disclaimer. I currently don't have any affiliation with U.S. Air Force, so any opinions expressed here are my own, and they're not necessarily the official position of the federal government, the U.S. Department of Defense, or the United States Air Force. So I still have to always remember to throw that out. But my role there was really about then finding, okay, we have email and other kinds of, we'll say, academic systems that the students needed access to. But given that we were this federal institution, we still had a lot of rules that we had to follow to make sure that we were doing that in a secure way, that we were being respectful of privacy of the data, and that we could still interoperate and do research and help out the Air Force as well. And so it was a really cool job. It was a great way to end that career. I certainly learned a lot about how those things are done and the compromises, that are made to bring things to reality.
When we hear about the government in general, but the U.S. Air Force as one of them, right? You just naturally hear hey, long procurement processes, things move really slow. You have a bunch of bureaucracy, nothing gets done, right? I'm guessing that's not really the case. Describe to us, actually what is going behind the decision making when you are adopting a technology platform or solution as you're kind of moving forward.
Yeah, it's a fantastic question, Shomik. Thank you. This took me a long time to really understand. I worked in, we'll say, procurement kinds of roles for several years before that. Sort of doing the lead architecture stuff. You're doing a lot of requirements generation and RFIs and RFPs and things. And what I really came to understand and appreciate is where in private industry we optimize the processes for procurement around efficiency. In the U.S. government in particular, and I'm sure this is true in other public sectors as well, we really optimize for transparency. And that's really important given that we're these stewards of taxpayer dollars. And so there's got to be a fundamental fairness there. You can't ever have even the hint of nepotism. Given the nature of the mission as well, that it's national security and national defense, you can't cut corners the same way. And you just don't have accountability the same way that you do with like officers of a company or something necessarily. And so I really did come to appreciate that it's like, oh, these do feel like a lot of hoops. And, the federal acquisition rules, I'll be honest, felt onerous at times. But, having done that for years, I really did come to appreciate how essential it was to both, national security, but also to promoting a sense of fairness and transparency to the, ultimately the procurement decisions that we made. I think it's one thing when you're the owner of a company, you can go hire someone that's a friend of yours. It's all very relationship based. You don't really want that in national defense. You don't want people sort of using their friends for contracts. I mean, as you can imagine, that can get problematic very quickly. The other thing is that the funding model is so different as well, that you want also transparency around making sure that the dollars are being used in a way, you don't really have like a board of directors that's comprised of like, we'll say active investors or whatever happens in private industry as well. I've, done the startup thing, and, that's sort of the check and balance there. And you just have to come up with it differently, when you're doing procurement in let's say the public space. I came to appreciate it. I will be honest, at times, there are, I think there are improvements that can be made. I'm not going to say that it's perfect, but I did come to appreciate that, it's a team comprised of a lot of hardworking people. I do think that there are optimizations. I'm sure they figured some out. I'm sure they'll continue to. So, I obviously wish them well.
Let's talk about, modern AI. So given that, right, like we all know data is really important for kind of the AI story, but as you talk about what an enterprise needs, like you're going to a random enterprise that's just saying, hey, listen, we're trying to adopt AI. We're trying to figure out what to do. Like, kind of what do you tell them from a high level standpoint of like, here's what you need to think about for your data?
Yeah, it's a fantastic question. I think it's one that is a consideration that's often overlooked. Just a little bit of a background about me. I do have a lot of background in machine learning. It's what I went to graduate school for, artificial intelligence. I've spent most of my career as either an ML researcher or someone who's commercialized AI-enabled technologies. And, one thing that I've learned in that time, one truism, is that really great data with off-the-shelf models always outperforms, we'll say, limited data with best-in-class models. And so a lot of our customers, I think there's always this natural bias to sort of chase what's getting all the attention. We need to invest in the latest and greatest models, and we need to hire the legion of PhDs in data science to make sure that we're engineering the very best architecture of neural network, and we're using the latest generation of big model transformer or whatever. Those things do matter. I mean, but I will say at the periphery, and said maybe a bit differently, if you don't have your data state correct, it just, you don't even get the chance to sort of be accurate later on with the models. And so the first thing that we always encourage our customers to do is to focus first the investment in making your data discoverable and trustworthy and secure, making it reusable so you can actually have, some kind of governance program. So the time to market of new insights is much faster, and you can more readily use these models. I mean, it's one thing with humans, I think, are reasonable at seeing something and seeing a data set and seeing it's incomplete or seeing that something's been normalized incorrectly or whatever. But when you automate processes like that and you use these, we'll say these black box ML models, it can be very difficult indeed to detect, we'll say issues in data quality. So much of AI governance and sort of AI accuracy, it really is incumbent on data governance and data accuracy. And so we really urge them, there's sort of the steak and sizzle metaphor. You really want to the sizzle looks a lot of fun, but like you really want to make sure you get a good steak, which is really about investing in the data.
Yeah. Well, let's say they have that data investment now, right? And they're starting to think about kind of, real-time applications and leveraging data streaming. I think whenever I think data streaming, right, my mind immediately goes to latency as like kind of the primary driver. So, you're a bank, you have some transaction data, you want to stream that, you want to process it for risk scoring and things like that, and then be able to just kind of manage those transactions as they come through. I guess, like, is that the right framing? Like, is latency the primary need for data streaming, or should we be thinking about something different?
Sure. I think that's a fantastic question, one we get asked a lot. Certainly latency is the right sort of way that I think a lot of people approach data streaming. I would argue it's not the only one. I would even argue it's not the most important one. How I got into it was from a latency perspective. We were working cybersecurity risk, and we had lots and lots of telemetry that was being generated. We were doing, basically cybersecurity identity analytics. So trying to assure the people in your network are who they say they are. And the only real way to do that well was to basically validate every authentication that was happening. For a big global enterprise, that's tens of thousands per second. And so putting that data at rest, it was infeasible. And so that was a really good real-time data streaming use case to then apply models and other things too. But what I discovered sort of having gone through that process is that while, we'll say the latency was the thing that got me into it, there's this decoupling power of these data streaming, technologies, that it decouples not just the systems, but the teams and technologies as well. That's really helpful for development, for, reliability of software, and for time to market. To explain that a little bit more, event brokers 30 years ago were sort of invented to decouple systems. Something could produce information, something else could consume a bunch of information, and neither had to think too hard about what the other was doing because they had this common operating model to exchange data. So the producer didn't have to think about, am I overwhelming this poor consumer by shoveling data at it too fast? The consumer didn't have to think about is there a bunch of back pressure on the producer or whatever? Am I sure that these messages are did they actually get there? They've been acknowledged. We had infrastructure that did that for us. Well, now with modern data streaming platforms, we've not just, streamed data, we've also allowed the ability to normalize and add governance to it and connect it all over the enterprise. And so when we do that, we don't just decouple systems, we now decouple teams and technologies. And so the teams can develop independently because they're separated only by these well-contextualized, well-governed data topics in a technology like Kafka. And because of that, you don't have these big monoliths anymore. People can work independently, and they can also deploy and operate independently as well. Microservices have been, I'd say a great enabler for promoting data streaming technologies. Event-driven microservice patterns are, really kind of taking the industry by storm. And I think that in many cases, that's not necessarily a latency problem. Sometimes it is. But I think that what we found is it actually just helps us reason about how we build organizations, how we share data, how we scale beyond that single team to really build really great software. And so for me, latency is a big part of it, but I think that decoupling power is also really important as well.
Traditionally, right, when we talk about those producers and consumers, the consumers were typically like a data warehouse or data storage, some sort of database, right? Ironically, now you have what you guys are doing around the Flink ecosystem and just everything. You have this kind of sort of like in-stream processing kind of capability. And so, one, can you describe what that is? But two, also, I guess, does that change the paradigm of hey, first you have to stream it to something and then analyze it? What sort of use cases or what sort of kind of things is it enabled by being able to do it in stream?
This is a lot of, I think, what dominates our current thinking and the products that we deliver to market, and what, kind of the future of data streaming platforms is we think about what we call our shift left paradigm. And so you're right. The traditional paradigm was exactly what you described of we took data from whatever operational data store and we put it in something else to run some kind of analysis on it. The cloud data warehouse, the data lakes, those kinds of technologies where I, build a big data cube and I'd run some very sophisticated OLAP kind of thing on it. And there are some challenges with that. The first one is that information flow tends to be one direction. And so we have a bunch of systems and data that are powering the business, and we'll call it the operational estate. And then we move over in kind of a one-way sort of integration path, using these data pipeline things. These data engineers sort of cobble these things together. And, some enterprises will have tens of thousands of them. They can't rationalize them. There's amazing amounts of redundancy, but then they go into sort of like a job per job, kind of one-to-one bespoke fashion into that warehouse where they can populate for a dashboard or, generate a report that some decision maker, once a quarter looks at or something. And, I think in the sort of the old state of business, that was good enough. But I think the technology's improved and the speed of decision making is improved. That's no longer adequate. We need to make decisions in real time as well. And so that analysis needs to feed back into the operational state of data as well to make sure those systems are, let's say, running the business appropriately, that the business logic reflects sort of what we've learned from extensive analysis of the existing data. And that can be a real challenge. There's this cottage industry of, we'll say, reverse ETL tools that try and do that, and it's very kludgy. And so what we promote is this idea of shift left, where you're using technologies like Flink and Kafka and our governance in concert to make data this reusable asset. In fact, that's how we define the data streaming platform, is it's that set of capabilities that's necessary to make data this reusable asset, to make data a product that's discoverable, that's secure, that's trustworthy. In order to do that, it's when data is produced, I apply some kind of governance to it. So I can reason about its provenance later on, where it came from, how trustworthy it is, enforce some kind of contract over it, that it needs to have this form, it needs to have, kind of this kind of description. The values need to be between, these kinds of bounds that, per some kind of business logic. And then I can then, transform it using a technology like Flink to better contextualize it. You think of like the way data is stored in many of these operational systems, a relational data store, for example, we really emphasize normalization. And some of that is, I think, an artifact of the legacy of, 40 years of doing this, where storage was a real constraint. We didn't want to expose application developers to update and deletion anomalies. So we stored everything just once. And we did a lot of work to do that. The problem with that was with an event, sort of two foreign key references in a tuple or whatever are not useful for anybody to action upon. And so you do need to denormalize that data. You need to contextualize it well to actually make events. And that's where technologies like Flink can help. Because once I've done that well, what we find is that, for the really important data sets that power a business, they don't just have one consumer. They might have 20 or 50 or more in a really big enterprise. And so rather than do that process multiple times inside some kind of ELT workflow inside a data lake, do it once inside something like this, and then everyone can consume it and everyone can trust it. And then for time to market increases too, because the next time someone needs to pull something off the shelf, well, it can be discoverable. They can look into a data portal and a catalog and figure out what's out there and figure out what to use, so they don't have to go through the very onerous process of modeling data all over again. And so that's really what we think about. And so it's not like we replace those analyst tools. We just change the consumption patterns for the way data moves throughout the enterprise. And so you still are going to have the warehouse and the lake. It's still going to be critically important, but it's not necessarily like the black hole it once was, where everything sort of goes in there and it becomes a swamp and I've got redundant data. And it's hard to reason about what the canonical source of data was.
How do you think about, though, you mentioned that kind of like bringing the data back to the operational, product or whatever. In that case, like, to use the term, like, you typically, whenever we think about it, right, you subscribe to a Confluent topic, the producer sends it to a consumer, right?
Yep.
But what you were just talking about, like, does that mean that you could actually be, like, it's not just producer to consumer, like the consumer could also be sending stuff back to the producer to then do analysis on and send on back? Like,
so this is actually, the last, few of our big industry events are currents. We've announced a really exciting new capability we call table flow. And I think the key insight from that is that, in the operational part of the business, app developers, the, systems of record themselves, they like to consume data as streams. It's nice. Events happen. They see new events. They can incrementally, process them. That's a great pattern for them. For analysts, for the data scientists of the world, the people that do that kind of OLAP processing, the stream isn't really a great paradigm. There's no reason a data scientist can't write a Kafka consumer, but they don't. And so what they really like to consume is data as a table. You look at like Delta Lake and, Iceberg and some of the other prevalent systems, especially with open table formats, which we're a big fan of because they decouple, again, the processing and the storage of some of these things, which is, something we've done in streaming a long time. Yeah, basically, if I can materialize data in a Kafka topic as a table, either, something like Iceberg, well, then the analyst can consume it how they're used to consuming it. And then they can update that table again, and it can, materialize back into the topic later on. And so I got this consistent view of data that acts as a bridge between these two very disparate communities in the past. And so, this is something we're working on now. We've announced, and, we're really excited to, keep advancing the state of the art here, because we think it's a really important thing. It's something that has resonated so well with our customers, this table flow concept.
I'm just curious, like, in an agent-based world, right? Like, does the concept of Kafka topics, like, I don't think it goes away, like, because it's still that concept, but like, does it start to get automated or something, or do agents change that by any chance in your thinking?
I think there is like different abstractions that we promote. And I think that like table flow is a really good example of that. This data product thinking that is so important in the industry right now, that, different personas want to consume data, the same data, a consistent view of data in different ways. And so I do think that, we're in early days with agents. I do actually think streams are pretty appropriate for agents as well most of the time. Though, I think that there's different paradigms and different patterns for how one kind of runs and operates multi-agent systems. But yeah, you think of like what an agent does is it typically observes its environment. And so that's great for something like a topic because an event happens, it consumes it, it decides to react or not. These things tend to be very stateful. So what often happens is it just persists some view of it, or some other system does that and the agent interacts with it. But yeah, that, the topic does, I think, tend to be a good, data construct for that. If you look at the conceptual model of how they see the world, something event driven is, I think resonated with me, and I think it's resonated with what we're seeing in the market right now. I do think though that there are times then where some event happens, these agents do tend to be reactive. And I think that's the difference between sort of like, we'll say an automated process and an agent is the autonomy or agency, if you will, that agents have. They're not sort of on guardrails. They're not following prescriptive workflows. They're reacting to the world around them. And that tends to be very event-based. There's some event that's going to do that. But at the same time, they also need to be able to consume different kinds of data differently. It's not all event-based. Yeah. Something happens, it's like, oh, some alert got generated, or something happened that it's expecting to see. And it's going to need to interrogate the environment in a way that's, we'll say, not event-driven. It needs to know like what happened over the last hour with all of these systems, and it's going to have to query something probably more approximating a table. And so I think that, we think a lot about those consumption patterns, and you actually need both. And so that's why we've, thought very hard about how we bring that to market.
Am I right in thinking that like actually, the whole event streaming paradigm probably benefits the most from, O1 or whatever the newest model out of OpenAI is, but it kind of seems like training may not necessitate as much streaming as inference would seemingly rely pretty heavily upon that, because you need to be constantly updating the model with what's coming through. Is that does that match your view of the world, or how do you kind of think that changes the paradigm?
Sure, I think you said it perfectly. I think that's exactly right. Maybe just to expand a little bit, in my career, we think a lot about, what these ML ops things kind of used to be. And they tended to be these very batch oriented sort of serial steps that one did. I'd go out and do a bunch of data curation. Then I'd do a bunch of feature engineering. Then I would do some model training. Then I would do some bias characterization. Then I would do some testing. Then I would more testing. Then I would, actually deploy the thing. And maybe I did that once a week. And for many sort of, we'll say, predictive processes, that was maybe good enough. That sort of, the world didn't change that frequently that we got away with that. With generative AI, you're exactly right. With these foundation models that sort of, we spend a lot of time training these on huge corpora of data, all over the world. And then we sort of let them go, and, others can treat those like black boxes. I think it's really transformational. I think of the whole time I've been doing artificial intelligence, it always seemed like a really big thing, but it always seemed like 3 to 4 years away from being relevant. We were just on the cusp of it changing everything. I'll say this moment feels different. And I think the reason why, if I had to sort of state the key intuition, is because these foundation models being reusable, it makes them much more accessible. I no longer need this legion of data scientists and statisticians to like do the art of like, massaging a neural network to fit exactly what I need it to be. But the data engineering challenges remain exactly as you said. And now, instead of being part of that feature engineering and model training process, now they're much more real time because I incorporate them as part of the inference process. The retrieval augmented generation for many applications is sort of the best thing we have right now for getting the best answers out of these things and minimizing hallucinations. And in order to deliver the sophisticated reactive experiences that our internal knowledge workers and our external customers have come to expect, you want that to be done in real time. You don't want someone to like ask a question and then say, oh, we have a bunch of cascading batch oriented data pipelines in the background, so we'll get you an answer in 6 hours. Nobody likes that. Again, we find if people are waiting more than seconds, they get frustrated. And so that's where data streaming really matters, because it's about sort of matching the speed of the LLM, which is something that can take in the order of seconds. And so I need to find, in many cases, to do something like a RAG oriented, workflow, I need to find the right, most relevant domain specific information wherever it is in the enterprise, and couple that with the prompt to get the best answer. And what we find the really important patterns there with, populating things like vector DBs or doing other kinds of data staging, you sort of have different patterns for structured data versus unstructured data, but data streaming is incredibly relevant in all of them, because you want to make sure you have the most relevant, and that by really means up-to-date data. You look at things like semantic search, and people have studied this. Most of the time when people are doing a search of data, there's a real-time component to it. They're actually looking for something recent. And so, that ends up just being really important. We don't want to rely on cascading sort of data pipelines that may take a day to power our applications. So yeah, data streaming is very important in this, we'll say, sort of new paradigm of AI.
This is going to be, I'm kind of curious if this is how you kind of think about it, but we were talking about that kind of in-stream processing and those materialized views and stuff like that.
Yep.
For inference workloads though, like, is that as relevant? Because what I would think is, like, you need to have the streams, right, coming in, and then you almost want to process all of those streams together to understand what's happening, versus like, hey, this I'm saying one stream, but obviously there could be a lot of data in it, but like just that one stream versus processing that and seeing like, oh, here's what's happening, now let me act upon it, right? It's almost like you want to have everything together to act upon. Is that kind of what you would say as well, or how do you kind of think about it?
No, for sure. I think we see with customers that there's one thing with, we'll say non-trivial, we'll say workflows. And so a lot of what we find our customers are actually getting value from with technologies like generative AI is it's not really replacing people yet exactly. But what it is doing is making our internal knowledge workers more productive. And if you look at what that is, there's a lot of times where we ask humans to synthesize sort of disparate, heterogeneous data and make some kind of judgment about it. And, that can be aided by summarization or by isolating the most relevant things. And that's something that the foundation models are, LLMs are really good at. And I think you're exactly right that if we look at some of the very sophisticated things our customers do, there's not a single source of information that is contextualizing those prompts. It's many. And that's where, again, I think that the data stream can be really helpful, because unlike these more, we'll say, sort of, kind of other paradigms where you're putting data at rest and storing in a certain way, the bigger data gets, the more, we'll say, specialized one has to be in how data is organized and queried. So if you look at like using a wide column store, which I love, but you kind of have to know ahead of time what questions you're going to ask, because you have sort of a column family, kind of per query, basically, in order to sort of denormalize across and make that thing fast enough when you're trying to read from it. Well, the specialization of data streaming is that data is meant to be consumed. That's how it specializes. And so, you think of what LLMs need to do. They need to consume the data. And so they're not going to be wedded to these very rigid data patterns that you sort of are forced into with some of these other, we'll say, kind of development paradigms where you're putting data at rest. And so, yeah, data streaming is I think, incredibly useful for, exactly what you described.
When I think about like just, we've talked a lot about like the technical infrastructure, right? And like we've gone deep into the technical, but like I kind of want to bring it up a little bit. Like, is there like a AI customer use case leveraging data streaming that you can just bring to life for people that are listening? Like, and maybe it's one or two of them. You don't have to name the customer or anything, but just like kind of, what's like a common thing that you're seeing in the customer base? Yeah,
I think first thing I'll say is I think we see, I'll say, faster adoption amongst those industries that are more comfortable with black box ML, with some of the particularly generative AI kinds of use cases. And so, that tends to be financial services and med tech. But, we've got, a cancer research center that's doing a really cool application where they're doing a kind of one-shot training, where doctors see patients and they want to maximize the time they spend with their patients, maximize the time they do research. They want to minimize the time in which they're doing record keeping, in which they're annotating notes. And so one thing that they've done very successfully at this place is they actually do one-shot training of, this is the format of what we think the record of a patient visit should look like. And so the doctor can make a few notes. It can pull in as context elements of the EMR, the electronic medical record, and it can present like, hey, this is the template to follow for this is what we want to insert back into the EMR. And then the system basically suggests, hey, doc, is this what you meant to kind of put in, based on this chicken scratch over here, these sort of salient things you said and what we think this record ought to look like. And then the doctor then can, instead of starting from scratch, they can quickly check and verify, make a few updates, which then, they're not doing this yet, but they hope to then use some reinforcement learning to sort of make the system better. Not doing that yet. Right now, it's just one-shot training. But even already, they estimate that they're saving between 25 and 30% of the physician's time on, you will say, the data entry part of outpatient visits, which is, you think of how valuable a doctor's time is, and also how important it is from an engagement perspective to keep them doing the things they love doing. That ends up making a big difference. And so, that's a really cool one. Some of the other ones that, this is a little recency bias, but I guess one I saw fairly recently was, insurance firms are automating aspects of both underwriting and claims processing using generative AI. You think it's all peril specific, of course, but there's a lot of we'll say like heterogeneous sort of record data entry in a lot of these things. So talking to a title insurer, for example, they have, every county in America has a different way of representing what a lien looks like and what a deed looks like. And mortgage paperwork will vary by bank. And it's really helpful for, the data entry part of underwriting. A big part of what you ask them to do or ask someone to do is isolate the objects within it. This is the underwriter. This is, who the lien is against. This is the property. This is the buyer, pulling all that out. LLMs are very good at that. And so being able to put the records in and isolate, this is what we think this looks like, and sort of structuring, the underwriting call to what's a more traditional risk model is something that saves a lot of time as well. And so, we have a customer that believes that they've increased the throughput of sort of, within an hour, an underwriter can process, between 2 and 3 times as many applications as they used to using that. Because again, that one is a very, so we'll say like data entry intensive process. I think that in a sense is what we're seeing in the market right now. Again, I think through when I talk to customers, and the more ambitious their applications sound right now, the more I try and caution them. It's like, hey, try and build some muscle memory first, because it's amazing to me how much, really good value is derived from just automating some rote aspect of some internal knowledge worker's time. The best these things can get in, sort of the current state is you maybe get them, they're 95% useful in terms of the number of outputs that are actually useful versus not. That's a wonderful thing if you're sort of automating parts of work and there's a human in the loop validating it. Obviously, it's unacceptable if it's making a decision about your customer. You don't want to blow up 1 out of 20 customer interactions. And so, we see a lot more sort of internal sort of enablement and greater productivity, far more than we see customer facing stuff. There's a little bit of that, but even that is more about like, hey, you're doing something and we're going to help you do it a little bit faster. So it's still, in a sense, the same kind of use case. But that's, I think, what we're seeing in the market a lot. And these very cool, I would say, sophisticated workflows that are chaining together inference steps to yield some kind of useful outcome. I think the other thing that academia and just empirical experience in industry has shown us is that the LLMs tend to do better if you can sort of decompose your problem into very small, very specific kinds of prompts rather than try and ask the whole thing at once. And so data streaming is really good at kind of decoupling those various steps of the process. And that's something that we're seeing a lot. I'll be the first to admit, though, maybe I'm a little biased because I work at the data streaming company. I'm the data streaming AI person. And so the customers that are kind of coming to me probably already have that bend in mind. But for me, it is remarkable how useful we'll say that data infrastructure aspect of it has been in actually productionally, and operationalizing these applications. I think it's the difference between these things being sort of science experiments and actually being something that creates ROI for our enterprises.
I think also the point that you mentioned is not just the efficiency of that the doctor can go do more things or the underwriter can go and do more, but actually also I assume when a platform like Confluent is sort of managing that, probably the data quality itself is also better. And so if you think about it from like a patient outcome perspective, it's like, you don't want a doctor who's tired at the end of the day just trying to input all their notes or something, and then they, by mistake say somebody's blood type is different than another's.
Yeah.
And I think some of this sort of what data streaming and AI will enable is sort of almost more, consistency of records, maybe, or just like more, again, like this data quality aspect is something that I think, at least personally, will be better when it's automated. But I don't know if you agree with that.
I absolutely agree with that. One of my research areas that I spent a lot of time with, more than a decade ago, I'm probably showing my age a little bit, was this thing called the semantic web. And the idea is that we would ask, web providers to annotate everything they produced with these tags, and that would help semantify this data so machines could understand it, and you could make more sophisticated querying patterns and find relationships and do lots of really cool things with ontologies. And it's funny because I think we actually got to the promise of the semantic web. It was just not in any way the way people expected. What really happened is machine learning got way better at semantifying kind of, text, of understanding. We had skipgram and these other things that helped us actually understand through, creating these like embeddings and vectors that we still use all the time, these mathematical representations of data that preserve their meaning. Those were really big advances that weren't anticipated back then. And so in a sense, we sort of got it, sort of despite the content, creators never really playing along. And I think that the same thing happens though in a different form with data today, that there is a lot of problems with data governance that create a lot of challenges downstream from people that try and use data and try and like play detective later on like, what is this and what does it mean? If you think of what governance is, most of what it is metadata creation. And, people that, the app developer that's making the stuff, they don't always want to think about it. They want to kind of move on to the next thing. They're not necessarily thinking about how others are consuming this. And so as tools, we can make these things really helpful because they're so good at helping sort of annotate that stuff. Here's a 50 sample events, or here's some producer code. Suggest a schema. Here's 50 sample events, describe what these different fields are. Suggest some business metadata around who the owner of this should be and where this should resolve and what you think this stuff is actually describing. And if, I think the developer sort of sees that and they can kind of make a quick correction, I think we're going to get a lot more metadata and a lot more data governance than we've ever had before when it was incumbent on those app developers to basically make it all themselves from scratch. And so I do think there's a really unique opportunity here because the LLMs are just so good at, helping describe and recognize these, we'll say these basic kinds of patterns. I think there's this ongoing academic debate to what extent are these things reasoning agents. But I think for that kind of thing, they're absolutely good enough for adding value. And again, I wouldn't like take the human out of the loop yet. Yeah. But, I think that we're seeing that now when we think about the way we build our customer experiences too, ways we can add those kind of touch points to help make our customers more productive and increase data quality the same way. So I think you're absolutely right.
We've talked a lot about like what it enables for customers and all of that, but like I also think there's something really cool about like internal Confluent technology. Not like hey, Confluent sales team or eng team. Like obviously AI is going to benefit all of that, but I'm saying like the actual product itself. Like something I imagine is, for example, from a UI perspective, even the having to classify the Kafka topics and pick those out and stuff. Like you could see a world where like an agent is learning that and then is automatically suggesting for you like, hey, this is probably what what you're looking for, or like the cluster maintenance or the scaling or something like that. Like, is that something you all are thinking about? Like what are you kind of broadly thinking about? I guess if you can't disclose, like just in that sort of vein.
Yeah, I mean, what I can say is we announced last year our sort of Confluent AI assistant, which our customers are all, free to use in public preview. It's the standard kind of disclaimers that everyone has on these agents right now, where it's like kind of, hey, it's best effort, it's an AI. So it may not be totally accurate, but it's amazing how engaged our customer base has been with it. It helps with a lot of things like characterize their spend or understand, where idle clusters are, do other kinds of, sophisticated things. And we are, again, I can't really sort of we're publicly traded, so I can't really talk about roadmap stuff here exactly. But, understand that I hear you, and we are absolutely thinking about ways in which we can, refine and improve and create a really amazing customer experience using these new technologies. And yeah, I think if you look at what others are doing in the space, we think a lot about how, data quality, you'll say ops can be made better and easier and, we have more predictability in consumption and how we actually deploy and use infrastructure. And yeah, those are all things that, we're all considering. And I'm excited to have some more announcements there soon.
Yeah. Okay. Got it. Of course, all disclaimers and everything in there because we can't talk about certain stuff. So yeah.
Exactly. Yep.
But if we're just kind of let's like zoom way out and just say right now, data streaming plus AI, right? Like, what should people think about? Like, is it kind of like any or many inference workloads will necessitate streams to power those? Is that, and so like if as inference workloads grow, like presumably then the amount of streams should also grow alongside it. Like just kind of what's the macro like zoom out take for streaming and AI?
Streaming is great. I think that's a great question. So I'll say kind of in the past, data streaming always maybe had some relevance here, maybe on the periphery. But as we've gone on and then we've had more Gen AI kinds of workloads, we've had more reinforcement learning come up and happen and be industrialized. And, we'll say more of the modern techniques of reusable models and things. And the more sort of, we'll say like real-time contextualization of models. Real-time training is becoming a thing that it was never, I mean, it's always sort of been there, but I'd say it's a lot more common than it was 10 years ago. And so I do think that the way that, AI is evolving as both sort of a community and a technology and this enabling capability for business, it's becoming much more real time. And so, yeah, I think that you're exactly right. I think in the future, we're not necessarily going to have, I think businesses think sometimes like, okay, we have our single AI application and we bring it to market and we're done. I think for the very competitive firms 10 years from now, they won't have done this once. They'll have done this a dozen times or 100 times. And when you do that, I think it's so important to have this common operating model to think about, how data is discovered and contextualized and secure and made, trustworthy. And I think the real challenge with a lot of bringing those things to market, particularly in light of the reusability of the models, it's about, where the data is and if the right data is available. And so I think of the time to market of not the first one, but the time to market of the 10th one or the 100th one. Data streaming is going to always help that be faster, because again, the whole intention of it is the data is meant to be consumable. You're not going to be wed to some particular data model that you got locked into with this particular database. The next, really cool application that you couldn't even imagine today that you dream up later. Well, the data is meant to be consumable. So you're in a place where you can readily set up the next thing based on the latest, small language machine or the really cool, central LLM thing or whatever it is you're going to be. I mean, I think at least for a while, I don't think we're going to get to some kind of crazy universal model. I think that there's going to be, kind of what we've always had, that, the models are a little bit fit for purpose. And I think there'll be a little bit of transfer learning. There'll be a little bit of fine tuning. But the problem with these stochastic kinds of processes is it's very difficult to understand, okay, maybe I made this thing a little bit better, but how do I test what it forgot? Because it's, there's necessarily, something that was lost because I'm manipulating what it learned. And I think that that's a really important observation for most people that don't have the legions of PhDs in data science working for them, is that what the name of the game for them is going to be about, taking really good models, off the shelf and then contextualizing them with domain specific data in real time. And that's where streaming can really help. I think particularly when we get more into agents as well, where we actually have, not these prescriptive workflows, but, these technologies are reacting to their environments and they're collecting data, maybe in ways that aren't entirely anticipated, but should be planned for. That's where also, again, making a really consumable pattern for data is just so critical. So yeah, I think you're right that the data streaming is going to constantly matter more and more.
This is not for you to say, but for me, there's been a lot of public investors that have talked to me about, for example, monitoring companies and how they can view it as an attach rate to cloud spend. And I think frankly, I think streams are kind of have some component of that to inference workloads, and I think what will be agentic workflows in the future as they increasingly become more real time and need to use that data. So, but Andrew, I guess thank you so much for the time and for walking through this. Where can people find you? And also, is there any announcement that you want to call people back to that you guys have recently announced, or user conference or something like that that's coming up that you'd like to shout out for folks?
No, Sean, I really appreciate the opportunity. So yeah, please find me on LinkedIn. So I'd love to connect, love to explore if there's ways we can help, enable AI for your business. We also have our current developer conference coming up. We have 3 of them globally, actually. So the next one is going to be in India. We've got one in London in May. And then this fall, we have the one in New Orleans. This is the kind of the Americas-based one. We would love to see you. And again, please reach out. We can talk about if there's, ways that we can help you attend.
Well, thanks so much for the time and for the conversation. And I think a lot of cool insights here for everyone to dig into.
Sean, it was my pleasure. Thanks for the great questions. I had a lot of fun. I'd love to come back someday. Thank you so much.